Hello guys, today we'll be talking about our new chapter which will cover the topic of our chapter 3 and chapter 4. So we'll begin chapter 3, and for notice I would do all the calculations and all those stuff at the end of the unit. So let's start off with chapter 3. So chapter 3 is about atom, elements and all those stuff. So first of all we'll start with atom. An atom is the smallest piece of an element that can still be recognized as that element. So this is one atom of an element, which is the smallest unit of anything, even our human body, which is the smallest thing. And these atoms combine together, join together to form molecules. Alright, so these two join, or more than two join together to form molecules, and they are joined chemically by covalent bonds. Covalent bonding will be dealt in the next video, and then we'll talk about the structure of the atom. So an atom has a nucleus like this in between, and then it has orbiting shells like these. Alright, so in the nucleus there are two structures called as proton and neutron, and in the orbiting shells or the energy shells we have electrons. So these electrons orbit around the nucleus, and now for example carbon is an element. It has 6 protons and it has 6 electrons, and remember that proton is a positive, it has a positive relative charge, and electron has negative, as the table here has shown that that proton has a relative charge of +1, that protons has a relative charge of +1, that they are positive, and electrons have a relative charge of -1, which means they are negative. And because of these two, negative and negative, as they are being negative and positive, it keeps balance in an in an atom, and keeps it relative constant, or should we say neutral. And neutrons have no charge, which makes them neutral, and the masses, proton and neutron have same mass, so they make 1 1, but electron has 1 over 1836. You should remember this. And then we have energy shells, or should we say the number of protons in an atom's nucleus is called the atomic number, and the mass number, sometimes known as a nucleon number, counts the total number of protons and neutrons in the nucleus of the atom. Mass number equals number of protons plus number of neutrons. Number of neutrons equals mass number minus atomic number, and number of electrons equals number of protons. So these are some rules, that if the number of proton is 6, the electron number would be also 6, and the mass number is the number which is given truly to the whole element and a whole atom. And in exams we have like these scenarios. In exam we count these. So this is the mass number. The highest one is always a mass number, and the highest one consists of neutron and proton both together. It has both together in it, and it has neutron proton added together. And here down we count the proton number or the atomic number, which gives us the element number also. So nucleon number is known as mass number, and mass number is known as proton plus electron plus proton plus neutron, and the atomic number is known as a proton. And we'll talk about isotopes. So isotopes are basically atoms. Isotopes are atoms of the same element which have same atomic number, like this number is same, but they have different mass number. It can be 60, it can be 61, it can be 62, it can be 63, and they have the same number of protons but different number of neutrons. So atomic number equals to proton number, which means it remains same, but the mass number changes. As the proton number is same, obviously the neutron number should be changed. So an atom where neutron number is different but the proton number is same, and then we'll have a calculation about finding the relative atomic mass of an element named as boron. So the question is actually 10, B means something like an 11B, which is confusing because it is written, but it should be like this: 10 here and B here, and the other one should be like this: 11B. So this is how it should be, these two, and these are two occurring samples in the environment. So we'll find out our relative atomic mass by this. So 20% is multiplied by, so our 20% is multiplied by 10 bracket plus 80 into 11 over 100. So we have done this. I'll explain this, that this 20% would be multiplied by the mass number like this for the first atom, and then we sample, and then we'll have 80% multiplied by 11 of a sample, but we are finding in a smaller form, so we'll divide it by 100, and our answer would be about 10.8, which is the proper, or should we say the perfect relative atomic mass of a boron sample which we got. And then, as I said in the beginning, the atom is a smaller space of an element which can be recognized, and then we have that they bond together to form a molecule, and then this atom which has nucleus in between, which consists of protons and neutrons, and then we have electrons which are moving all around the nucleus cause of the attraction, called forces of attraction. And then we have the atomic number is the mass number is the nucleon number, which consists of proton and neutron together, and atomic number is known as proton as standalone. And then we have isotopes, which are atoms of the same element which contain different atomic number, different nucleon number, different mass number, different nucleon number, and different neutron number, and they have the same proton number. So we'll move on to chapter 4, which talks about the periodic table. So first of all, I would like to say that vertical columns in the periodic table are called groups. Like this, in this same horizontal, the horizontal rows are called periods, and the vertical columns are called groups. So this is first group, second group, third group, fourth, fifth, sixth, seven, zero. Zero, I will talk about zero group, and this is how we label the periodic table as in the name of groups. And then we have horizontal rows in the periodic table, like this is the first one, second, third, fourth, fifth, sixth, seventh. So this is not considered as groups or periods, the lantanoids and the actinoids, but periods are in the horizontal and groups are in a vertical. As I explained, the electrons move around the nucleus in a series of levels called energy levels or shells. Each energy level shell can only hold a certain number of electrons. Lower energy levels are always filled before higher ones. The lowest energy is the closest one to the nucleus. The first shell can only hold up to 2 electrons, second shell can hold to 8 electrons, third shell can hold up to 18 electrons, and the fourth shell can hold up to 32 electrons. Alright, but in our course we write that third level or the third shell can withhold 8 electrons because we have to only draw until calcium, not after that. So considering that, we'll say that there is a nucleus and there is a energy shell. The electrons are constantly moving around it because of forces of attraction, but the nearest or the closest one is having the lowest energy level. Lowest energy level is the closest one of the, so there is the lowest one and there is the strongest one. So this is how it happens, and then we say energy levels allows electrons to orbit around the nucleus. So I'll draw for oxygen. Oxygen has I will draw for carbon, which means carbon has 6 electrons. So there is a nucleus. Alright, and this is the first shell. So as I say, first shell holds up to 2 electrons. Just cross it to label as electrons, and the second shell can hold up to 4. So cross here, and cross. So there is for carbon, and then I'll draw for hydrogen. Hydrogen will be like this, one shell only with 1 electron. So it is simple. And for calcium, you know, obviously that you have to draw 4 shells because 2, 8, 8 and all those stuff, but you have to remember this in a secret way, which is I will explain here. Elements in the same group in the periodic table have the same number of electrons in their outer shell. So this is the group number, and this number means that there are this number of electrons in the outermost shell. So if we are talking about beryllium here, it has 2 electrons in its outermost shell. Then we have boron here, it has 3 electrons in the outermost shell. Outermost shell is a shell which is at the last, or which has the highest energy, I should say, according to this point. And then we have this number of electrons in the outer shell is the same as the group number for groups 1 to 7, which I just explained. And the period number gives the number of occupied shells or the highest occupied shell. So this gives us the amount of shells in each of the element. So if rubidium is we are drawing rubidium, it has 5 shells. And then we have elements in group 0, which in group 0 are known as noble gases because they are almost completely reactive. In fact, the two of the at the top of the group, helium and neon, don't react with anything. The elements in group 0 have 8 electrons in the outermost shell apart from helium, which has 2. The lack of reactivity of the elements in group 0 is associated with their electronic configuration, and noble gases are unreactive because the outer shell is full and there is no tendency to lose, gain or share electrons in chemical reaction. So when a chemical reaction occurs, atoms tend to give or take in electrons, and they share or gain electrons, which allows chemical reactions to take place. But this group doesn't share electrons or gain electrons, which doesn't allow reactions to occur, which means they are unreactive, almost unreactive. Then we'll talk about the difference of metals and non-metals. So the metals in this group, the transition metal here, as we have seen here, and then we have elements from this. You would draw like this, a stair. You can see this in the book also. So this is one example of all the metals and non-metals. This region consists of non-metals, and this whole region consists of metals. I'll leave this thing about this bottom part. We are not talking about this, we are talking about the upper surface part. So this part is non-metal and this part is metal. As you can see, many elements are metal and less elements are non-metal. So we'll talk about the differences. The first difference is that metals generally form basic oxides and non-metals generally form acidic oxides, which is something we'll learn in the second unit. And metals tend to be solid with high melting point and boiling point with relatively high densities, and but there are exceptions such as mercury as a liquid. But for non-metal they have lower melting and boiling point. Exceptions are carbon and silicon. So there's one difference: high melting and boiling point and low melting and boiling point. And metals are shiny, have a metallic luster when they are polished or freshly cut, and non-metals tend to be brittle when they are solids, and they don't have the same type of shine as metals. And metals are malleable, can be hammered into any shape, and ductile, can be drawn into wires. But non-metal are brittle, which is the previous point. And then metals are good conductors of heat and electricity, but non-metals are bad conductor of electricity, except for carbon and silicon. Again same example. And then they are poor conductors of heat, and the exception is diamond, which is the best conductor of all time. And then we have, they form positive ions in the compounds, and they form ionic compounds. Ionic compound is in the next video. And non-metal form both ionic and covalent compounds, and they tend to be negative ion in the ionic compounds. So this video was all about elements and atoms and periodic tables, so and metals and non-metals. So I hope you like the video and subscribe my channel and spread my